Okay, so this is HYSYS. I used HYSYS to relate the conversion to the duty. So how to use HYSYS? You start with new case. Okay, you go for add. You add the. It's not like Aspen. Here you start adding everything, then you go for the spreadsheet, whatever. So my reaction here is gonna be methanol plus O2, which gives CO2 and 2H, 2H2O, 2 molecules of water. So here at the beginning, you go for add and you add your component. So you click twice, wait for the component, or you just go for add pure, and then here you type O2 twice, CO2 twice, and H2O. Then that's it. This is about four or three important things: the component, then the fluid package. You go to add, and you choose here. It depends on the reaction. Now it's just conversion, so you just go for an RTL. Okay, you just choose an RTL and you click here. Then go for reaction. You add the reaction. It's just conversion reaction. Add reaction, and here you add your all the components you have. Okay, so as you saw here, it's the coefficient is 1. You add minus 1 here, the minus 2, right? No, yes, minus 2, and here 1, and here 2, and here, sorry, here 2. So here 2, here 1. So right, yes it is. Okay, and then you need to click on balance, so it calculates everything. And oh, okay, you go for bases, and here in the CO, you see this is conversion, the conversion equation. You just, the most important one here is CO, which is the conversion, your conversion. I don't know, here it's just random. Since it's random example, I put 100, the conversion is 100. And here you specify, you choose which component is the limiting, the one which will consume first, the conversion of this one. Okay, once you get this one green, which is ready, sometimes it's not green, so you go back here and balance. Okay, if it's not green, you need to check those coefficients. The one in the reactant with minus, you write the minus. It's not like Aspen when you just add the number and it's automatically takes the sign. Okay, that's it. Okay, that's it. You go for here reaction set. You say add to FP. So add the set for the fluid package. You have to do this to find the reaction and the package in the worksheet. Okay, so the reaction here you add as much as reaction you want. This is first reaction. You can add second reaction as you go. And then most importantly, add to FP, which is at the fluid package. So three things: component, fluid package, and reaction. You can find more information about this in YouTube. You just write how to use convergent reactor in HYSYS in the YouTube, and you find the same thing. And then finally you go for into simulation environment. Okay, so this is the simulation environment. You go for convergent reactor. So where are the reactors? This is it. This is the general reactor. You just click on general reactor, then choose which one. It's the conversion. It's the third one. You put it here. Okay. Now you click twice before, yeah, you click twice, and it's not like Aspen. You just put the name of stream. So inlet, of course, you have whatever number of inlets. Okay, you just have one. This is the name. This is the name. You can add whatever. I just choose one as a name, and this is the. You have one product or two product, whatever. You have one product, just as much as here by default it's two. You can just delete this one, and you just have one product. Okay, and here it's the energy, the duty. Okay, the duty, this is the name of the duty, just name, not the value. It's just, you see how you just add, say, Q, the name. You can see here, as you saw, the streams are added automatically, and this is one for the duty. It's more, it's very important. Okay, now of course it's not, still everything is not ready, so you go here for the feed. Now in the feed you specify things. Since it's random reaction, of course you add your conditions. So I choose 25 degrees Celsius, and here say 1, and 1 watt 1 is 1 bar. Okay, now this is for the conditions. That's the other values will be calculated automatically. You don't add the variable, you add one of those, two of those three. The third is automatically calculated when you add the component. So you add the component, but you need to add them again here. So this is the amount. You just add any number randomly, and it will shows another. It will shows, since it's small fraction, you need to put something below 0. This is randomly. Now you choose here. You can choose whatever the unit or the basis. So since it's random mole fraction, so the methanol, say it's 0.6, and the oxygen is 0.4. Okay, so this is mole, so 0.6, and go for 0.4. Sorry, 4. That's it. Okay, you go for, okay, if you need to add mole flow, you can say it's 60 and choose the unit, and this is 40. Okay, and those are the products. If you have them as reactants, you can add them. If that's okay, you find here the total, you go for okay. You see everything is alright. If you go back, you can find it's already calculated. This is the things you added. Okay, the other things are calculated automatically. Okay, now it's red, that means it's not processing yet. Okay, so you go here, okay, here you go for reactions. You need to add the reaction, so you go here, set below the reaction, and you see the reaction is there. Okay, you can change the conversion. If you will need to check the conversion, you go for view reaction. After you add it here, go for view reaction basis. You see this is the 100. You can change it from here, and then you'll find how much the duty is. Okay, now it says that unknown duty. If you have the duty, it will calculate automatically the output temperature, but what we need is the duty, not the output temperature. So what we do, it's two options. Either you provide the outlet temperature, that means it calculates the duty, or you provide the duty, which will calculate automatically output temperature. In this case, since we want the duty, we go and specify the output temperature and make the reaction isothermal. So you go press here and you specify the output temperature, which was, since isothermal, 25. So you got this green and you got this green. That means now it's already calculated. Now here you don't need to press run, because this is the run solve active. It's solved, automatically solve everything. Okay, so now this is all is solved. Now how to get the duty? Now for 100% conversion, you got the duty of, you can just, you put the mouse on the Q, which is the duty, and you find the duty is minus, because it's exothermic, 1.7 to the power 7 kilojoule. How to find this number? You press here twice and you go for the parameters, you find the duty. So 100% conversion corresponding to duty of this number. Now you take this number to Excel, and in the Excel you put the conversion, or like this. Now here you can copy, okay, you can just press here, Control C, and you got this, okay, and this is correspond to 100. Of course, I recommend to do this in Excel. Now how to change? As I said, view and say 50, okay, so it's 50 conversion. You just, it's automatically calculating everything. You go back to design parameter and you got this new value. So this new value corresponding to 50, okay, and here we go. Since the conversion is 10, okay, the duty changed. Now it depends on your reaction, okay. You see here the duty is the same. I don't know why, whatever. This is because of the chemistry of the reaction. It depends on the reaction anyways, and so on. So you choose the conversion as much as numbers you want, put the conversion, and then you go back here. So the conversion here in the reaction, you choose the conversion you want, say 25, enter. So you write it here and then enter. You go back, design parameters, and you get your new value. So you take all values in Excel and you draw them. That's it. Okay, thank you for your